Welcome back to Further Solutions Academy. Further Solutions Academy. Don't forget to share our videos, subscribe if you have not subscribed before. Kindly subscribe and leave a comment so that we know how to moderate our videos, just in case. This video I'll be working you on disconnected sets and connected/connected sets. It means by the end of this video you will understand this two things on this video, which is connected, and if a set is said to be connected and if a set is disconnected. Okay, now let me try to give definition to connected and disconnected. Okay, look at this definition. S is a subset, S is a real number. It's said to be disconnected if there exists this joint open set X is not equals to A, such that X equals to A union B, which is closer of A. This is A closure intersection B is equals to empty. A intersection B closure equals to empty. It means A and B are not non-empty set. They are not empty set. Now A intersection B is empty, and A and B are open sets. Now it means this thing, when you have something like this, we call it separated word set. Now S is equals to what? This and this, which is S is a what? Disconnected. S is already disconnected. If that happened, then not satisfied is connected. Not satisfied is connected. Now this is the image of what I've been telling you. This is called connected. This is called disconnected. Can you see how it is? This is called connected and this is called disconnected. I think I can break up and have it what and call it X, and also I can have this and call it what? X. Now, and this X is connected and this X is not, connected, and this one is disconnected. That is all about that. Now you can see that the major thing is that their intersection is empty, and union is equals to the what? The given set. That will let us to know whether it's connected. Once that happens, it means is what? Disconnected. But if that does not happen, if the intersection generates another thing, it means it is connected. Now let's talk about. Let me try to show example. Okay, let me show example that will illustrate what I've been saying. Okay. Okay, look at this example. Okay. Now look at this very good example. Okay, look at this question. Check check whether X, which is this is my X, and disconnected or not. How do I solve this thing? Now, the first solution to this problem, I want to check whether connected or not connected. The first thing I will do is that among this set, this is the set of X is given to us as 1 union 2 and 3. Now, since I have this, don't forget that I can say that A equals to 0, 1, and B, it means A is not empty. That is what I'm trying to say. And B can also be equals to 2, 3. It means B is not also empty. Take note of those things. Now, if I want to interpret this normally, in a normal way, now, it means I can say my set S can also implies, I can say generate a number line like this, which I have is 0, is my origin. I have 1, I have 2, and I have 3. Now, and so on and so forth. Now, what I'm trying to do is that this particular area is my A. This particular area is my B. Can you see? Now, Can you see? That is what I'm trying to do here. Since I know that my A is given, my B is given, I can now say that now if I should move on to my closure of A, which is going to be, we have done closure earlier, and B closure is also 2, 3. Now, and both of them, A and B, A and B are not non-empty. Are not empty. Since I know that are not much empty, which is now closure, sorry. These are closure. It means when you have something like this, it means closure. This also means closure. Closure of a given set. Please, we have done that earlier. You can check on our video on that. Now, from here now, A intersection B is empty. And A intersection B closure is also empty. And also I can say that okay, this is called, we can call this place separated sets. Now, and move on to the A intersection B. It means A intersection B is empty, and A union B is equals to what? What's our A union B? 1, 2, 3, 4, which is going to be what? C, which is going to be 1, 2, 3. You know, we know what it's called. Union is going to be 1, 2, 3. That is my now it means equals to what? Equals to X, which is the X given, because you can see 0, 1, 2, sorry, 0, 1, 2, 3. 0 is also there because we're talking about 0 and interval. Sorry. Okay, you can see it's also equals to X, since it means X is disconnected. X is disconnected. That is all about that. S is disconnected. Now, don't forget, the major thing you need to test, you test for the what? The union of if it gives us the real sets, and also the intersection, if it gives us what? Empty, that is the conclusion to satisfy that this is what? Disconnected. Now, let me try to show another example of this case that will really help us to, you know, to understand this concept very well. Okay. Now, look at this question also. Now, look at this question. Now, look at this question. It's another simple one that we need to understand. This is my X, this is my tau, which is my topology. Now, check whether or not S is what? Disconnected or connected. I think you should know that one. Now, the next thing you need to do here is that it's a very simple question. Anytime I have something like this, I want to check whether or not the given set is connected or disconnected. Now, what I need to do is that I will look for my open set. Now, I can turn this one to what? From my open set, which is going to be, this is my open set, which is my tau, I can call this place A equals to AB, and I call my B equals to what? ABC. Very correct. Now, since I have that, now leave X and MC alone, just leave that alone. Now, let's talk about the intersection of this given set. Can they be equal? What is their intersection? Intersection, oh, I think there is one more set on this place. Let me put set C. Set C is there. I have my set C. Okay, now, intersection of these two, I don't need to go like this, not to avoid confusion. Don't let me go in this form so that you will not confuse yourself. Now, I can pick A union C. What is my A union C? A union C is A union C. What is my A and my C set? It will be equals to ABC. ABC is not equals to what? X. Not equals to what? X. Not equals to X. And let's talk about the intersection. Since this is opposing, let's move on to A, B, junior, B, C. Now, can we see that this is also the same thing as what? A, B, C, which is not equals to what? X. Since it's not equals to X, your conclusion, it means X is not disconnected. Disconnected. It means what? X does not connect. That therefore X is connected. X is connected. Because number one, I've checked for the union. The union is not giving me X back. Assuming the union give me X, that will make me to proceed to the what? To their intersection, which is their intersection of this. I will now go for their intersection, and you can see intersection of this set, which is going to be when I have A, B intersection B, C. Definitely, this is not empty. This is not empty. Definitely is not empty, because you can see that their intersection is equals to A, B, which is not empty. Not empty. Now, since it's not empty, it means the given set S is what? Is connected. S is connected. Now, let me show another example before I end this video. Can you see? Now, another example before I end this video. Okay, look at this given example also. It's a very nice one that is very simple also. Now, solution to this problem. How do I go? The first thing I need to do, don't forget that the major thing is that the intersection of a given set must be empty, and their union must give us what? The given set, which is the normal set. Now, that is those two things that would satisfy the condition that is what? Disconnected. If not, it means is continuous. If not, is continuous. Now, let's check what we need to do. Now, from the given set, let's move on to the first one, A, B, C, union D. It will surely be equals to X. Oh, that condition number one is satisfied. It will be equals to 1 is satisfied. Now, the next thing I need to do is that let's go to their intersection. Intersection D, which is going to be what? Empty. You can see nothing, no common region between them. Then X is disconnected. X is what? Disconnected. If that is not the case, it will be what? Connected. You can see example on connected and disconnected. Don't forget you are home with Further Solutions Academy. By now you should understand the meaning of connected set and disconnected set. Once again, share to your friend, subscribe, make sure you leave your comment for moderation. Don't forget Further Solutions Academy. Thanks for watching.